This video is produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this video, we'll be looking at how sequences are used to calculate pensions under the Financial Maths section. We'll also look at an example of how sequences are used in a question involving pensions and savings. So case 3 is pensions, where case 1 was savings from a previous video and case 2 was loans from another previous video. So suppose we want to receive a pension of €P every year for T years. So what this means is when we retire, we want to be taking in P every year for, let's say, maybe 20 years. But we don't need to have the full amount of the payments P times T in the account at the beginning, as interest can be gained. So after the first year, we receive the first payment, so there has been 1 year of interest. So therefore, the amount needed in the account at the start of the first year to cover this payment is P all over 1 plus I. So for example, if we wanted a pension and we wanted something like €100 every year for 2 years, to save that initially, we wouldn't need to put in €100. Because let's say we had an interest rate of 1%. That would mean that 100 all over 1 plus 1%, or 0.01, is equal to 99.0099. So that means to actually get €100, we need only put in 99, as we will gain interest. So in fact, any payment after n years can be covered at the beginning by P all over 1 plus I to the power of n. So here we're taking account not just of the first payment, but of all payments. So we can use this to make a geometric series for a total required at the beginning. So S sub t will be equal to P over 1 plus I plus P all over 1 plus I squared plus, and so on, plus P all over 1 plus I to the power of t. So once again, we have the geometric series, or sequence, sorry. So this time we have A, our first term, being P all over 1 plus I, and our common ratio R being 1 over 1 plus I. So again, all we need to do is throw all of these things into the formula in the tables book. So this formula is listed here. S sub t is equal to A multiplied by 1 minus r to the power of t all over 1 minus r. Now in the tables book, t will be written as n. For us, we're using t, as t in our case, it's representing time. So again, throwing all the pieces in, A becomes P all over 1 plus I, and R is 1 all over 1 plus I. And rearranging this, we end up with P multiplied by 1 plus I to the power of t minus 1 all over I times 1 plus I to the power of t. So we're looking at an example to see the application of geometric series for savings and pensions. So let's say you are 30 years from retirement and want to start saving for a pension. So starting 1 year after retirement, you would like a pension of €20,000 per year for 20 years. So how much do you need to save per month from now until retirement to cover this pension? We assume that this money can be invested at 3%. So first thing we do is work out how much is needed on the date of retirement to cover the pension. So each payment of €20,000 made n years after retiring has a present value on the date of retirement of 20,000 all over 1.03 to the power of n. So the total needed on the retirement date is given as follows using the geometric series formula. 20,000 all over 1.03 plus 20,000 all over 1.03 squared, and so on, all the way up to 20,000 all over 1.03 to the power of 20 after 20 years. And that leaves us with 20,000 over 1.03, which is our a, the first term, all multiplied by 1 minus 1 over 1.03 to the power of 20, all over 1 minus 1 over 1.03. So our common ratio is 1 over 1.03. This gives us €297,549.50. So this amount needs to be covered by saving P at the beginning of each year for the next 30 years. The value of these savings with interests needs to match the pension requirement. So we know that this €297,000, 549.50 is going to be equal to P times 1.03 plus, and so on, all the way up to P times 1.03 to the power of 30. So this pension, the €297,549, must equal to the savings, which is the right hand side. And again, we use our geometric series formula to throw all of these numbers in. We end up with P times 1.03 times 1 minus 1.03 to the power of 30, all over 1 minus 1.03. And that's equal to P times 49.00267,818. Rearranging to find P, we end up with P is equal to €6,072.11.